Okay, class. Today we are going to continue with our energy unit and learn about electricity. By the end of this lesson, you will be able to understand what electricity is, understand features of static and current electricity, and analyze the behavior of current electricity. But first, what is electricity? Electricity is a form of energy resulting from the existence of charged particles, such as electrons or protons, either statically as an accumulation of charge or dynamically as a current. Electricity is everywhere. Even though we do not see electricity, it is all around us and in everything we do. It's in the alarm clocks that help us wake up in the morning, the cell phones we use to communicate with our friends and family, and of course in our homes and classrooms where we use computers and light switches. Where does electricity start? Electricity, in a nutshell, is the flow of electrons. Electrons can be found in atoms. What you see here is an atom. An atom is a form of matter, which is anything that takes up space. Electricity begins within these atoms. Inside an atom, there are protons and neutrons in its center, which is called a nucleus. Surrounding the protons and neutrons are electrons. Notice the similarity of words, electrons, electricity. Now these electrons are moving around and around the nucleus so fast that their rapid movement creates energy, which in turn generates electricity. There are many forms of electricity. For example, when we rub our feet together on the carpet really fast and then touch someone else, that's called static electricity. It is the same type of electricity that causes lightning to appear during a thunderstorm. Another form of electricity is current electricity, and this is the type of electricity that we are going to be focusing on. This type of electricity is what we mostly use at home and at school. Current electricity happens when a stream of electrons flow through a conductor. Conductors are materials that electricity can flow through easily. These materials are made in such a way that electricity can flow through it easily and freely. Some good examples of conductors are copper, which is mostly in the form of wires, water, people and animals, and trees. In class tomorrow, we will be creating our own current electricity by combining batteries and conductors to a light bulb. We will also be using a light switch. This is called an electric current. An electric current circuit is the path that electrons follow. In order to have a complete circuit flow, electrons need to have a path, a power source of some sort that will help push the energy flow, and a function or a job that the electrons have to fulfill. What do you think will happen if the path is interrupted? This is also something that we are going to discover about tomorrow. Okay, that's it for now. Please bring any notes or questions you may have to class so that we can discuss them before we get started on our experiments.